A very good day to all watching this video. In this video, I will be talking about the concepts related to the formation of a concentrated urine. So we first need to understand about serum osmolarity, then the urine osmolarity. Serum osmolarity, that is the osmolality of serum, urine osmolality, which differs slightly from serum osmolality, the requirements for the formation of a concentrated urine, and finally the mechanisms by which the urine is concentrated. So serum osmolarity, urine osmolarity, the requirements for concentrating urine, and the mechanisms by which urine is concentrated. We shall first begin with serum osmolarity. Serum osmolarity, as you all know, is the total number of solutes in the plasma, and the total number of solutes are mainly the sodium ions. So serum osmolarity is equal to total solute concentration upon the water. That is total body water. Now this solute concentration is contributed mainly by the sodium and associated anions like chloride and bicarbonate. 4% is contributed by glucose and urea, and the rest by plasma proteins. This serum osmolality is 285 milliosmoles per kg H2O. Osmolarity varies with the temperature, therefore we use the term osmolality. This serum osmolality is tightly regulated around 285 milliosmoles per liter, so per kg. So even a 1% change in serum osmolality results in release of or inhibition of the release of the hormone, antidiuretic hormone, and change in urine osmolality. That is, the urine becomes either dilute or more concentrated. This urine osmolality, the normal is about 300 milliosmoles per liter, but its range is between 50 to 1200 milliosmoles per liter. So if it goes to the left, it is dilute. Between 50 to 300, it is dilute, and about 300 up to 1200 milliosmoles per liter is the maximum concentrating ability of the human kidney. It is concentrated. So even a 1% change in serum osmolality will bring about changes in the urine osmolality. And to form a concentrated urine, we need a number of things. First, we require the hormone ADH, or antidiuretic hormone, which is secreted by the posterior pituitary gland. The hormone ADH, also called vasopressin. But ADH is a term which is more appropriate because it is antidiuretic. It is vasopressin under very high concentrations. and medullary osmolality, high solute concentration in the medullary osmolality. Both these we require in the presence in increased amounts, because in the presence of high medullary osmolality only ADH can reabsorb large amount of water. ADH can reabsorb. This is the main point, that in the presence of ADH only, in the presence of high amount of medullary osmolarity only, ADH can reabsorb a large amount of water. This ADH is provided by the osmoreceptor ADH feedback. The osmoreceptor ADH feedback tightly regulates it. So when the osmolarity increases, there is increase in ADH. When the osmolarity decreases, there is decrease in ADH. And then there is a counter current mechanism, which is multiplier and exchange. Multiplier is contributed by the loop of Henle, and the exchange is contributed by the vasa recta, the special type of capillaries in the medullary nephrons. In addition, there is a role of the hormone urea, which is a waste product of the body. So we have seen about serum osmolarity, urine osmolarity, concentrated urine. Requirements are ADH and high medullary osmolarity, which is provided by the osmoreceptor ADH feedback, and the counter current, multiplier and exchange mechanisms, and finally the urea, which is recycled. So these are the mechanisms by which the urine becomes concentrated by a high level of ADH, a high osmolarity of the